हेलो हाय एवरीवन। सो आज के इस वीडियो में जो हम लोग लीड कोड का क्वेश्चन नंबर 209 दैट इज मिनिमम साइज सब एरे इसको देखने वाले हैं। सो लेट्स सी क्वेश्चन क्या कहता है। सो वी आर गिवन एन एरे ऑफ पॉजिटिव इंटीजर नम्स एंड अ पॉजिटिव इंटीजर टारगेट एंड वी नीड टू रिटर्न द मिनिमम लेंथ ऑफ अ सब एरे whose sum is greater than or equals to target. What we need to find out? We need to find out first of all two things. We need to find the minimum length what sub array. Okay, first condition. Second thing is that subarray sum should be greater than equals to target. These are our two conditions. Okay, and if there is no such subarray, we return 0 at the end. What we need to do, we know that okay, after the if while loop whatever this is, we need to return a 0. Cool. So let's see with a test case. If you don't know what is a subarray, so I'll explain. Subarray is basically a contiguous part of an array, that is all the elements in continuation. Something like 2312 is a subarray, 4 3 is a subarray, entire this array is a subarray, each individual elements are a subarray, right? But if you say something like that, okay, this 2, this 1 and this 4, that is 2 4 1, this is not a subarray. Okay, all the continuous elements, maybe it can be of single length or maybe it can be of double length, these all are a subarray. Okay, so for to understand these types of questions which we have to deal with subarray, there is something called as sliding window approach. Okay, sliding window approach, if you don't know guys, then I'll explain in a better manner. So I'll have a array. Okay, and in this what we do, we have two pointers basically I and j, and these two pointers basically form a subarray. What I told you about that, since subarray is a continuous part of an array, so for this let's say from I to j, this is a subarray, and this there is some condition. I don't know what is the condition, but I know that okay, I'll have a subarray between I to j which will be based upon some condition, and based on this condition only we will increment our j value and increment our I value. Now the values of I and j can increment conditionally or non-conditionally, maybe increment by 1 or maybe decrement by 1. So what I can say is that maybe after some condition my I points up at here and j remains still here, and I have this as my subarray, right? This part will be again my subarray, and I'll check with this condition that okay, if this match we have a subarray from range I to j, correct? And these types of approach, that is the sliding window approach, is basically useful in case of a subarray problem. So let's understand this question with a example. So I have given array as, and we are given target as what, 7. Okay, so initially as I told you about, we will be having two pointers I and j. So what I can do is that I can have my both pointers initially at the 0th position, correct? That is I is equals to 0 and we will have a j is equals to 0. Okay, now since we have to find the summation of these elements, that is I need to figure out a sub array, okay, whose sum is greater than equals to target. So what in my mind says is that I'll keep on incrementing my j pointer, and I'll keep on adding these values, and we'll check if the current sum is greater than equals to target or not at any point. Okay, and if this happens, so what I can say is that okay, I have found one of my answers, since the question says I need to figure out the minimal length. So I'll just keep on updating my answer value. Okay, so what I can say is that I have these two values I and j, and I'll keep on going and I'll keep on adding these values into my answer variable. Okay, so for let's suppose I'll take for j is equals to 0, current sum is 2, that is I added this element, and j plus plus. So now for j is equals to 1, current sum goes 5, that is 2 plus 3, these two elements. Okay, now for j is equals to 2, current sum is 6, here j is, and then j goes off and j goes ahead, that is j is equals to 3, current sum is 8. Okay, now stop. Since the question says that we need to figure out a subarray whose sum is greater than or equals to target. What is my current sum? My current sum is 8, which is greater than equals to the given target, that is 7. Okay, so I found out a condition that what we can say is that if my current sum is greater than equals to target, what I need to do? I need to update my answer value, right? So answer will be minimum of answer, comma, the length of this subarray. The length of this subarray is from this portion, that is from I till j. I have this subarray and I need to figure out the length, that is j minus I, right? So I'll have answer, comma, j minus I. This is my one condition. I can surely say that. Okay. Okay. Next thing. Next thing now, since I have got my current sum, which is 8, which is equals to target, and what I can say is that if I keep on adding j, like 8 plus 4, it will eventually become 12, and 12 is also greater than equals to target. But since we need to figure out the minimum, and we already have till up here, this is 4, so adding further, I'll have length as 5, then 6, and so on, which will not give us the correct answer, right? So what we can do is that I can just shrink down my window. What I mean is that currently I have this as my window of length 4, right? Now, since current sum is already greater than equals to target, so what I can do is that I can shrink down my window by subtracting 2 from the current sum and incrementing my I. What I'm trying to say is that my current sum is 8, okay. And since current sum is greater than target, what I can say is that, okay, subtract from current sum, subtract nums at I, that is 8 minus 2, which is equivalent to 6, and increment my I. So I'll be here. Cool. What will happen after this? After this, I'll have this much as my current window, and whose sum is equivalent to 6, which is actually visible, that 3 plus 1 plus 2, which is equal to 6, right? So now this condition fails up here. Now what we can do, we can again increment our j and keep on adding the values to our current sum. Like so, from this much to this much is our subarray, and this is 6, which is not greater than equals to 7. So what we'll do, we'll just keep on incrementing our j. So I'll have this much part, that is we'll add 4 to 6, that is 3, 1, 2, 4, which is equivalent to 10, and again 10 is greater than equals to target, right? So I'll update. Since 10 is greater than equals to target, what we do, we subtract 3 from it and we increment I. Maybe I can write down the code and then it will clearly make sense. So let me add some pages. Okay, so what I can say that I'll have an answer variable. First of all, I'll initialize the values. I is equals to 0, j is equals to 0, and let's say I have a current sum value which is equal to 0, and n is nums dot size, and I have an answer value which is equals to what? Int max. Why int max? Since we need to figure out the minimum value, I'll initialize this value as int max, and whenever we'll pick the minimum, initially the value which is compared with answer will eventually be stored into the answer value, right? And since we need to return 0 in the end, so what I can say is that I can have a check at the end that if answer still remains int max, right, I can return a 0. Eventually I'll be returning 0. Okay, this can be condition added in the bottom. Okay, we'll move ahead. So what I'll do is that I'll be having maybe I can start a while loop where the j will keep on traversing till its length is less than n, and what I'll do, I'll keep on adding the current value into my current sum variable and will increment j. As I already told you here that keep on adding values and keep on incrementing j up till when we have current sum is greater than equals to target. So I can have another while loop, maybe as I have told you in this condition. Now the condition is that, let's see, in this, let's suppose I added j till something like the sum got so much bigger that I need to subtract 2. I subtracted 2 from the target, and still, let's suppose I initially had current sum as 10, and I subtracted 2 from it. Okay, so I'll get current sum as 8, which is again greater than equals to 7, right? So it doesn't make any sense of going further, incrementing j further. So what I'll do, I'll go at this index, and I'll subtract 3 also from my current sum. That is current sum minus 3 also. That is 8 minus 3. That is 5. And since 5 is less than equals to 7, that is our condition breaks up here. So I'll increment j in this scenario. Okay. What I can say is that I can have another while loop where current sum is greater than equals to target. And what I'll do, I'll update my answer first of all, since we figured out one answer. So answer comma j minus I. Okay. And current sum, we will subtract current sum minus num set I plus plus. While loop ends up here. And if up till this point answer is remain int max, I can just return 0, else we just return. Does this approach make sense? This is our final code. Does this make sense? What I did, I basically had variables initialized. I took out the n value and we initialized our answer as int max. Why int max? Since we had to find out the minimum value, I took answer as int max, just an opposite, so that whenever we take the minimum of answer comma anything, this value will always be smaller than answer, and eventually it will be stored up. Okay. What we did, we started a while loop and we keep on adding the elements in it, and we incremented j. Okay, so there will be a time when, let's suppose I had this value 3 plus 3 plus 3, and we had target as 7. Okay, or maybe I can have here as 4. Okay, and we have our target as 7, or maybe target as 8. In this scenario, what will happen is that I keep on adding nums at j. That is, first I added 3, then I added 3, this will equals to 6, and then I added 4 to it, which will eventually give me 10. That is, current sum is equals to 10, right? Now, as soon as current sum is greater than equals to 10, I need to store my value. That is, okay, I have this much of length of subarray whose sum is 10, which is greater than equals to 8. So my length will be what? Answer will be equivalent to 3, that is j minus I. Correct? I have stored this value. Now I decreased I plus plus from current sum, num set I plus plus. So first of all, what I did, I decreased 3 from it. Okay. So I subtracted 3 from it, that is 10 minus 3, which is equals to 7, and my I comes at this position, and we'll again check that, okay, is 7 greater than equals to target or not. Cool. Now, what's the point of taking a while loop here? We can do this by an if also. Then what's the need of while loop? So for while loop, what we are trying to do, let's suppose there is some random test case, and after subtracting these values, I had 9. Okay, 9 is greater than equals to 8, right? So what I need to do is basically figure out the minimum length in each iteration, right? Since I am subtracting one element, that is current sum minus any value, which gave me 9, and 9 is still greater than 8, right? So my length definitely reduced by one element. I can clearly say that. That's why we did a while loop, just to check for all the elements present, and we'll keep on subtracting the num set I value. So what is the time complexity? If we look at the time complexity and the space complexity, we initialize some random variables. So I have space complexity as order of 1, and since we are traversing each element nearly once, that is j goes till n, and the another while loop may or may not go, right, may or may not cover the entire array. So the time complexity will be nearly around order of n, nearly around, not exactly order of n, but nearly around order of n. So yeah, that's all for this video. Thank you everyone for watching.